We're going to start chapter 20 by talking about heat engines. So a heat engine takes an energy from a hot source, uses some of that energy to do work, and then waste energy is expelled to a cold source. And this process returns the engine back to its original thermodynamical state. And this concept is referred to as a cyclic process. And when we return our engine to its original thermodynamical state, that means the change in internal energy is going to be zero, and the change in some other property, which we'll discuss later on in this chapter, also has to return to zero. Remember, energy is always going to flow from hot to cold, so energy is going to be taken in at the hot source and expelled to the cold source. It's never going to go the other way around without putting work into the system rather than using the system to do work. So turning to the first law of thermodynamics, we are going to plug in 0 for the change in internal energy, which tells us that work is equal to heat. And we're going to refer to this work more specifically as work done by the engine. And this Q is going to be Q net, which is going to be the energy coming in the absolute value minus the absolute value of the energy going out. And we put them in absolute value because technically speaking, QC should be negative, but we don't want to double minus sign ourselves. So this gives us a relationship about the amount of work that a heat engine can do based upon how much energy is going in and going out. We define the thermal efficiency as equal to the ratio of the work the engine actually does compared to the amount of energy that is taken in. And you can either leave this as a decimal or you can multiply by 100 and turn it into a percent. And subbing in our other relationship we have here, we can also write the efficiency as 1 minus energy out divided by energy in.